Hello, everyone. Hope you can hear me clearly. Thanks, Sveiki, for the introduction. So today I'm gonna talk to you about one of the two solutions in the HSmartBPM project, as Sveiki said before. It is called HSmartBPM, and you can see briefly what we'll talk about today. Speaking about a bit for some things you may already know, like consortium and the objectives and challenges of this solution. Secondly, I'll speak about the solution itself, with some innovational parts and the interfaces that someone can find through our solution. And then for the experience of the pilot sites, which is very important and quite new for us, and I think we can all obtain very valuable incomes. So, as Sahil said before, I am from Normal Informatics, which is the leader of the consortium you see below. It is compiled of CERT, ARC, Promptly, Data Wizard, Mindment, and we are also consulted by the Athens Medical Society in terms of, let's say, medical aspects of this whole solution. So here I conclude a bit of the objectives achieved throughout this, let's say, journey. Of course, we always had in mind to match the requirements of the procuring authorities and make the job easier, let's say, for clinicians and the caregivers by creating streamlined workflows, by creating a friendly notification mechanism, and of course, automating patient-reported outcomes. Predictive indication mechanisms are present in our solution, for which I will speak in more detailed fashion later. We created a shared care plan, which is a modular set of shareable information mainly between patients and providers. And of course, we are always talking about having a great concern for patient safety, for detailed data privacy and security mechanisms. Of course, we have a patient consent mechanism and secure clinical documents. Regarding interoperability, I can say a few things in some following slides. We had the pleasure to test this feature in one country and exchange some measurements with the national EHR. So some challenges addressed you can see in this slide. We of course want to early detect patients and risk of developing hypertension. The main aim is, as we said before, the improved self-management of hypertension and generally the prevention of these situations. We of course aim to provide certain evidence based on health outcomes and generally the quality of life from the use of information communication technology as it is generally used in this field, with new care models, in compliance always with data protection requirements. In general, we want to provide improved service offering, of course, both in medical ways and in business ways, because this is aimed to be a product, and this happens by leveraging the complexity of various healthcare systems under one unique platform. This is our main aim. Of course, what we briefly want is to impact the health domain in its several facets. Some innovation points found in our solution. You can see them in this slide. The early detection prevention component with the next 24-hour prediction algorithm and score charts. The shared care plan, which is modular and extensible, as I said before, which provides personalized guidance and, of course, better adherence to whole patient activities. Notifications and alert mechanism, which is the decision support system we have built, and it of course aims to better adherence to the care plan by the patient. Another component of drug-drug interaction by our Italian partners, Data Wizard, which can predict the potential medicinal therapy conflict. And of course, some features like virtual agent and social community, which both are chatbot and community component for users to interact with. Secondly, I will mention our platform, our solution we built in detail. Here you can see a catalog of our main components. As I said, the prediction model, 24 hours of hypertension event prediction, The early detection with the decision support system, which helps the healthcare professional to be notified about abnormal measurements and high hypertension values, measurements, sorry. The 10-year risk of CVD prediction, the shared care plan, which contains activities, medications, questionnaires that the patient can fill in, educational material that the patient can read or study, appointments, and in general interaction with his information and the healthcare professional according to his availability. The drug interaction component, the virtual assistant, where the patient can learn more things about the disease, the application, the devices that he is about to interact with, and generally be guided through the application. A dynamic consent mechanism, which is a control, let's say, for the patient to share his medical information with the healthcare professionals only on his demand. Visualizations, of course, for patients' adherence to the care plan. Those things can be seen both from the patients and from the healthcare professionals. And we think that it helps a lot, both of them to keep the interaction with the app. The community component and social component, as I mentioned before. A quiz game that we have connected with, let's say, the rewarding system, with the badges that the patient receives in order to continue the compliance with the care plan and the app's usage. Integration possibilities with local premises of patients, PHRs. This, of course, is also according to its pilot sites needs. Multiple devices integration possibility, and as I said before, the interoperability with HSM5 tablets and everything else. Some brief screenshots from our solution. The virtual agent, as you can see, someone can learn about the hypertension, like information, general information about devices, and about some medication that he wants to know more things. This is available both for the healthcare professionals interface and the patient's interface. The decision support system is a rule-based system that the patient and the healthcare professional can be notified about high values of any measurements requested. This is monitored by healthcare professionals web interface, as you see here, built by Seth. And it is tailored to his specific needs. He can choose how many notifications he can receive. He can choose the exact values to be notified and the occurrences that he wants to be notified in order to avoid notification overflow, which is another issue for healthcare professionals as it comes out from our discussions. Here you can see the predictive indications that I have spoken before. This is some list of the patients that you can see in the columns, the medication adherence percentage, CVD risk, which is calculated through the score chart. Hypertension prediction refers to the next day episodes, and is an algorithm that can, let's say, compile some information to indicate the percentage of facing a hypertensive event in the next 24 hours. And of course, this is with help of some neural networks to predict the next day, let's say, the episodes. This is previous work that it was implemented in. Of course, for more information on that, my colleague Andreas can answer many of your questions in the end. Here you can see another healthcare professionals interface about the education. The healthcare professionals can have educational material for the patients to view. It can be easily added in the platform, even from a library. It can be created even on demand. So it is quite easy to add a link or a PDF file, for example, in here and assign it to the patient so he can study it from his cell phone. Here you can see the dashboard of the care plans of a specific patient. They contain questionnaires, medications. You can see here in a separate, let's say, care plan, sorry, in a unified one that contains everything of this information. Here you can see the social platform that Cell has built, which is social media-like structure, and the patients can interact with one another, sharing news and experiences throughout this whole, let's say, journey. And here we show you some interfaces from the patient view, which is then built by the normal. On the first screen, you can see the patient's home screen. We keep it quite brief, let's say, with only important information depicting there. You see on the top you have the chatbot, the to-dos, my health section, find doctor appointments, and measurements bottom left, my fitness. In the second screen, you see the details of the measurements that come either from the devices paired or from integration, even by the patient themselves, in the case that we don't have an opportunity to transfer the measurements automatically for this specific category. And in the third screen, you can see a detailed view of a specific measurement, for example, the blood pressure here. You can see when the last measurement was held, the graph with its showing the blood pressure and the recent activity on the bottom, so the patient can be informed in a fast way how his values are evolving. This interface, of course, is also visible in the healthcare professionals' web application. In the fourth screen, you can see in My Health tab, where everything like allergies or condition or procedures, medication, everything of this kind of information is imported. If we have integration with patients' HR, previous events can be imported here, but any event that is further on to be scheduled can be imported directly in the application. On the left, you can see the first doctor screen. We have some filters, and on the top, and search by name. The My Doctor section refers to the doctors that the patient has already given consent to, so they can interact and the doctors can see the patient history. And below, you can search the doctor by specialty. You can, of course, book appointments with the doctor through the application. Of course, this is based only on the doctor's availability that was inserted, that has to be inserted before, so the patient cannot book an appointment whenever he wants, but only when the doctor is available. And this is both for physical or video one. In the first screen, you can see the care plan, how it's depicted on the patient's application. It has also adherence bars, so the patient can know what is his today progress and the overall progress, along with the to-do items and the detailed items assigned below. And then on the fourth screen, you can see a messenger-like structure that we created for the communication patient and the doctor, where the patient can make a quick question to the doctor, or the doctor can briefly have some news from the patient on his how this whole thing is evolving. And here, lastly, you can see on the left a specific doctor screen in the patient view with some information on the consent mechanism that can be enabled or disabled for the patient at any time. The patient can also choose if this is going to be limited or if it will expire at some specific date. The notification mechanism of the app is the second screen. The third screen is the chatbot. This is a Swedish example, but the patient can ask several things to the virtual agent we created, and he can get answers about medication or devices or information for hypertension, as I said. And the community component is depicted on the last screen. Of course, we have integrated some devices for the needs of the project. In general, we have integrated a lot of devices in the backbone of this solution, but the devices we use for this project are those that you can see here. The oral health guide was used for hypertension measurements, and the weight scales that you see below are split in each country, let's say. Here you can see a brief of functionality of our integration layer, which is built by Turkish partners, ERC, and it's called AHIN. And here you can see how it transfers information from our platform to the national EHRs each time. Here I have a very brief mapping of use cases in the, let's say, combined project, and in the right side are components from that we have built in this solution for the needs of the HSMonitor procurement. This is what I have mentioned before. And in the last part, I want to say a few things about the pilots. First of all, as an experience, it's very new in us, and we are very glad to participate in it because we can take very valuable input through this whole procedure, like interaction with users with the app, both patients, healthcare professionals. Of course, these discussions always come up in new features or editing existing features, which is very valuable, a very valuable opinion for us. We have built a separate technical support procedure because we have faced a lot of times, as everyone, many bugs that something's not working. We need to have a specific mechanism to deliver those solved. So we interacted a lot with the users and our pilot managers with that. And of course, clinical trial structure that we can see from a closer look, let's say. In the last slides, I have some graphs, indications for each country. Of course, we won't get in great detail. There are some metrics rising from the first results that probably are quite interesting for you to see. In the first screen, we see when users interact throughout the day. In Turkey, for example, you see that after early morning, we have a lot of users, but in late night, 9, 10 o'clock, we have quite more of that. On the right, you see some numbers like total visits or total page views and unique page views, indications that, of course, can hurt some outcomes in the early stage. Of course, the Turkish pilot was the longest one. That's why you see so high numbers. And in the graphs beneath, you can see at first the visits in a daily basis, and underneath the unique page views, along with all the pilots, let's say, time plan from day 1 to the end. Same structure follows for Croatia. You can see a bit differences in the first diagram that patients interacted most with the app in early morning and early night. Of course, the numbers are on the right. The numbers are lower because the pilot was shorter, and you can see on the last 2 diagrams the events of the patient, that have interacted with the app, and in the last diagram the direct entries, which are stabilized about 50 per day. So this was also, of course, for the patient number was rising through the pilot. And lastly, for normally enable some information, the structure is the same about the hours that patients interact with the application. As you can see, numbers are similar with the Croatian ones, and regarding events and the visits, same things follow, like stabilization of the users along with the patients, are coming in the pilot. For Naples, some similar things. The number is a bit higher. That's why the numbers here on the 2 below graphs are a bit higher. And in Sweden, we have some, let's say, small amount of patients, but the indications are same, only with the rise. As you can see in the midday, patients also interact with the app in the midday. And you can see again stabilization of visits when the patients were onboarded and they started using the app, which is the longest one. I don't want to say more things because we have more time. Big thanks to all of you that attended today, and of course to the procuring authorities for all this interaction for all these almost 2 years, both to the pilot sites and of course to the organization that support this whole project, like Empiric and Discipline. Thank you.